All right, here we go. Area practice test. Now, the first parts of this are going to be very similar to your practice quiz. So I'll zoom a bit so we see better here. First two are polygons, so we're going to use area equals base times height, straight up. So, base times height, 10 times 3.7. We can put that on our calculator and you're going to get 37. I guess the units would be miles squared. Oh, there you go. Number 2 is the same process. Number 3, triangles. Triangle formula is area equals base times height divided by 2. So we're going to do the same thing here. Base times height. 3 times 1.9 divided by 2. We can calculate that. We've got 2.85. Boom. Our units there would be miles squared. Number 4, again, same process. Number 5. Trapezoid. Area equals parenthesis base 1 plus base 2 times height divided by 2. Remember, you will have a note card for your test, so make sure you have these formulas down on that note card. So base 1, height, base 2. Remember, your height is really your distance between your bases. So we got 2.3 plus 6.3 times your height, which is 5.7. All divided by 2. I'm going to put that in my calculator. $24.51. Cool. And again, number 6 is the same process. For area of a circle, area equals pi r squared, where r is your radius. These guys are similar, but number 7 gives you the diameter. So you have to remember, oh, if the diameter is 6, the radius is going to be 3. Radius is half of the diameter. So we can go pi times 3 squared. So we're going to put that in our calculator. Remember, you can always use 3.14 if your calculator does not have a pi button. And if your calculator gives you a number like this, like 9 pi, hit that triangle button right there, right above enter. And watch what happens. Ta-da! Turns it into a decimal. Boom. Number 8, same type of process, except for it gives you a radius, not a diameter. Number 9 and 10 are also similar, so we're going to use the area of a sector formula, which is x over 360 times pi r squared, where x is your central angle. Of course, 10 is our radius, we can just square that. And then again, we go to our friend the calculator and put these values in. And I'm getting 65.4. There we go. Number 10 is the same process, same formula, so you can do those on your own. Let's check what we got here. These guys, find the missing measurement. Yeah. Alright. So these ones we're going to be working backwards. And just like the other side, you pretty much, the pairs are always use the same formula. So you've got polygons here. So you're going to use your formula area equals base times height. But these problems give you the area Here's your base, here's your height. We'll just put an X right there. So we've got area, which is this guy. 38.4 equals base, 6.4 times height, which is X. And next we just need to get our X by itself. So I'm going to divide both sides by 6.4. Cancels here. X is now isolated, so in my calculator, 38.4 divided by 6.4, and I get 6 straight up. Boom. That would be my height. 13 and 14 use the triangle formula, which is area equals base times height divided by 2. Remember, your base touches your 90, so does your height. We'll put an X right there. And then there's our area. We can put all these values into your formula. 44.5 equals base times height divided by 2. Well, we know 5 divided by 2, or I'm sorry, 10 divided by 2 is just 5. So I can go 44.5 equals 5x. And next step, I can just divide both sides by 5. And if I couldn't do that easy division, I could just multiply both sides by 2 and then divide both sides by 10. You're going to end up with the same value. 8.9 equals x. Done. Number 15. We have trapezoids. So area equals base 1 plus base 2 times height divided by 2. We have x, height, base 1, base 2. And we just throw these values into the formula. So 65.6 equals base 1. Remember, it doesn't matter which one you use for your base 1 and base 2, since you're adding them together. I will do this the long way in case you, I mean, we could say, oh look, 4 divided by 2 is, or I'm sorry, 8 divided by 2 is 4. But if you didn't have an easy number to work with like these, you'd times both sides by 2. This is one way to do it. And then you cross those guys. So 65.6 times 2. So we've eliminated that divide by 2. Next, I'm going to eliminate this 8. I'm not going to distribute because this will actually make the problem easier. So now I just divide this guy by 8. And I have 16.4 equals 5.3 plus x. And, sorry, we're kind of overlapping here. We're going to minus 5.3 both sides. And we're going to get 11.1 equals x. Wow. Kind of worked our way all around that problem. Whoosh. Should have had some more space. 17 and 18 are finding the radius of a circle if given the area. So again, we're working backwards. Remember, area equals pi r squared. We're given the area, so we substitute that right there. 16.1, 16.6 equals pi r squared. Divide both sides by pi. 16.6. Again, 5.28 equals r squared. How do we get rid of that square? Square root both sides. And let's get it. Again, about 2.3. Boom. There we go. 18, same process. And these guys here, the bottom 3. You will see a couple of these on your test, so you gotta know how to do these guys. And you always got to try to figure out what shapes are you working with here. Well, right here, I'll zoom in here. You can see you've got a trapezoid, and you pretty much just took a bite out of it. So you have a trapezoid, and you're taking out a half circle, right? So now you got to find the areas of your trapezoid and subtract the area of your half circle. Wheel, trapezoid formula. Oh, this gives me a 5. Watch this. I know this has to be 3 here because this whole base is 9. This is 6. So we're going to assume this is a 90. And so we have 3 left over. If you use Pythagorean theorem here to find the height, we can get a 4 right there. So you actually can do this. Don't use 5 as your height. Use the 4 as the height because it's touching the 90. And we know with Pythagorean theorem, 3, 4, 5 triangles will give you right triangles. So I'm going to go, area of my trapezoid would be base 1 plus base 2 times height divided by 2. Oh, my height is 4. And we can just solve that real quick. 4 over 2 is just 2. 6 plus 5 is 15. 15 times 2 is 30. So that's my trapezoid area. Now we're going to go over here and say, well, how big is this circle? Well, my radius is half of 4, because the whole diameter is 4, so half the radius is 2. So I'll do the circle formula stuff over here, so we can see it better. Pi times 2 squared, that's the area. So we can go, oh, I have to divide by 2, don't I, because it's a half circle. So 2 squared is 4, 4 divided by 2 is 2, so we can really just do 2 pi here. I'm getting 6.3 to the area of my circle. And now I just subtract these two numbers, the 30 and the 6.3. And that gives me my final area. These guys are not easy, but they just take a little bit of time and break down the problem. Boom. So this is the final area. Number 12 is similar. We have, wow, why are they continuing to give us triangles with no, you know what, we're going to cross out number 12. There you go. Lucky day. But we will do 13 together because we can do that one nice and smooth. This is the nice one because you can divide the shape on the grids. So we can go like this, and now all of a sudden you see you have a triangle, a square, and a half circle. So now we're going to find all those units. The square is the easiest. That's a 3 by 3. So base times height, 3 times 3. That gives you 9. The triangle is base times height, and I know this is going to be your height right there, so height is 3. 7's base, so I can go 7 times 3, which is 21, and divide that by 2, so we have 10.5. So up to this point, we've probably been able to do it in our head. But this last one, nope, we have to use pi. How big is your radius on this guy? Well, your diameter of the semicircle is 3. Half of 3 is 1.5. So we're going to go pi r squared divided by 2. And I get 7.1. Am I done? Just about. Now I gotta add these guys together. All of my individual angles, or I'm sorry, all of my individual areas. So 7.1 plus 9 plus 10.5. And we're ready to go. Total area equals 26.6. Boom. Woohoo. So again, a lot of these guys are breaking down a big shape into smaller shapes and then finding how to work with each of those smaller shapes.